Hi, welcome to readmeproject.com. The paper you have requested is on the impact of software evolution on software clustering. Let's have a look on our abstract. The evolution of software project is a rich data source for analyzing and improving the software development process. Recently, several research groups have tried to cluster source code artifacts based on the information about how the code of a software system evolves. The results of this evolutionary approach seems promising, but a direct comparison to traditional software clustering approach based on structural code differences is still missing. We conducted several clustering experiments with the established software clustering tool and comparing and combining the evolutionary and structural approach. These experiments shows that evolutionary approach could produce meaningful clustering results, while the traditional approach provides better results because of more reliable data sensitivity of the structural data. The combination of both approaches is able to improve the overall clustering qualities. Let's have a look on our data flow diagram. First, start the process and load source project. Identify all the classes in the source project. Then find structural dependencies and obtain method dependency. Then identify distance. Based on distance, cluster the classes. After that, plot dependency graph. Stop the process. Now let's see the demo of our project. First, we need to run main.java in clustersoft package. First, we need to select the source code. Source code instance, we need to select any Java package. Click the search button. Go to datasets. You will have a dataset named softclust. Here, select any packages. For example, I am selecting packages code. I am selecting any Java file. Then click load. Now select total class. It will show the list of classes in the particular package. In code package we have face computation, eigenface creator, face bundle, image canvas and JPEG. Likewise we have 10 classes. Okay, then we need to load the classes. So the classes are loaded successfully. Then click next. First, we need to identify structural dependencies. Structural dependencies in sense, we need to identify the number of methods and variables defined in each and every classes. So it will extract the variables and methods declared in each and every classes and for loops or decision making loops present in each and every classes. Then we need to identify evolutionary dependencies. Evolutionary dependencies in sense, we need to it will extract the common method used for source class and its dependent classes. So here face computation and face button have static void divide as a common methods. Likewise each and every classes have some similar common methods for their communications. Next we need to cluster the source codes. First we need to identify method dependency cluster. In method dependency cluster we will identify number of nodes and its respective edges. Here the nodes are considered as the methods used in each and every classes and edges are considered as the classes that access the common methods. In this example we will have a static void as a node and face bundle eigenface computation as edges. Likewise static double max as nodes and face bundle.java and eigenface computation Java has its edges. Similarly for public int getWidth and getHeight, it will have more than one number of classes, XXX file.java, face bundle.java, ppm file.java. Likewise we have similarly 8 classes for getWidth and getHeights. Then we need to go for class clustering. Here we need to identify clusters. It will identify the edges and its immediate edges. For eigenface computation edge, the immediate edge is face bundle Java. Likewise for image file viewer.java, the immediate edge is face bundle.java. So after identifying the edges and immediate edges, we need to identify agglomerative clustering. For that, first we need to calculate distance. The distance is based on cosine similarity values. It will calculate the cosine similarity distance for each and every classes. After that we need to apply cluster. In agglomerative clustering is a top-down hierarchical clustering. So it will show the number of classes and its dependency classes in hierarchy manner. Here image file viewer and ppm file.java is in one hierarchy, and ppm file test face recognition in one hierarchy. Likewise it will come in all the hierarchies. Then click next. Now we need to identify dependency graph. First we need to identify dependency graph 1. The dependency graph is displayed over here. To view it's in a circle format, click balloon button here. Then expand this. Click zoom. It will show the dependency information in a cyclic manner. It will show the number of methods that are interconnected between the classes. So here some of the files, for example public int width and int height, are connected to each and every classes in an hierarchical manner. Next click dependency graph 2. Click balloon. Expand it. It will show the number of classes interconnected in the packages. Here these are the classes which are interconnected between the packages. Now click performance analysis. The performance analysis is based on the Jaccard similarity matrix of the each and every classes used in the packages. That's all. The process is over.
Thanks for watching clickmyproject.com.